Hey guys, welcome to second semester physics. I want to introduce really quickly your first project of the semester, which you get some choices on, and that's always a good thing. Things are going to look a little bit different if you have to be at home versus if you are in class with us, so I'll kind of show you both ways for those of you that just aren't in class today versus those of you that won't be in class when they're due. So with our third quarter projects, you get a choice of three things to do. Option one is making a mobile using the concept of torque. And I will send you some information on what torque is. It's basically taking the force down, which is the weight of an object, times the lever length, and using that to balance. So bigger forces, bigger weighted objects will be closer to your fulcrum. Smaller things will be further away from your fulcrum. So you'll make a mobile, and then the thing that you will turn in will be a picture or a video of your mobile, and then this electronic or paper write-up where you describe your process. Now here's how I'm going to grade it. I've got a rubric here of 1 to 10 on these different things. Is it turned in on time? Did it work? Did you write up your process of how you decided where to place things so that they balance? And then this checkpoint thing I'm going to send you later in a Google form. It's just telling me, are you doing option one, the mobile, option two, or option three, which I'll describe in a second. So the checkpoint's part of it, the actual mobile's part of it, and then the write-up telling me what how you did the mobile will be a part of it. Now I'm including this board of different things here to give you an idea of what has been done in the past. And one of the things that I've included is this video that shows an actual mobile by a famous artist. They're called kinetic sculptures, and so they're sculptures, but they move and shift with the wind. So that's the idea behind this mobile, is using the weight and the distance between the attachment points, as you can see here, to create a moving sculpture. Let me see if I can find a big picture. So here's like his sketches of how he put them together. You can see the distances. Now his isn't, it's more art than science, but where he decided how big this was going to be, how big his objects were, and how it put together the whole thing. So you see two of these are weighted against one, so it's attached closer because it's heavier. This is attached further out because it's lighter. Okay, so that's the idea behind your mobile. The second option is you don't have to worry about the duet if you're working at home by yourself, but if you'll be back in class, you're welcome to work with a partner. What you're doing is creating some kind of a video, think like Bill Nye the Science Guy type video, using the idea of playground physics. So we can do rotational, we can do momentum, we can talk about kinematics, which is motion. So you're showing us how physics is used on the playground. The video itself will be a major part of your grade, of course, and then you can read all the little details there, but I'll grade it on, of course, is it in on time, the quality of the video and your examples, was it true information or did you just make it up? And then we'll have our classmates watch it and they'll get to give you a viewer's choice on how much they enjoyed it and learned from it. So again, the checkpoint that I'll send you of which one are you doing is a little piece of it, and then the video itself is due to me submitted. You can either put it on YouTube or you can put it in your Google Drive and send me the link, but send that by February the 8th. Now in that thing that I sent you, there's also a whole bunch of videos from the past. There's Simple Machines video, there's the playground physics here, so you're welcome to watch some of those from my previous students. Some of them are really funny. Newton's laws, potential and kinetic energy. Some of these are really, really great, and it'll give you a feel for what we've done in the past. Okay. The third and final option, if you want to work in a team, if you're able to do that, that's great. If you are at home and you can't work with a team, you're welcome to work with a sibling, but we're going to do, for your third option, a Rube Goldberg machine. And Rube Goldberg machines use the idea of the conservation of energy. You start off with stored potential energy, and as the machine runs, it turns that potential energy into motion. So in the machine, which I'll show you in a second, you need to include each of the 6 basic simple machines: lever, pulley, wheel and axle, incline plane, wedge, and screw in there somewhere. And then you need 10 machines or events in your big Rube Goldberg machine. Now, Rube Goldberg machines are all about using ridiculously long processes to do simple tasks. So your simple task is going to be scoring some kind of a point or a goal. So it could be rolling a little soccer ball into a net, it could be rolling a golf ball into a hole, but somehow you're going to score a point in a game, dart in a dartboard, whatever it may be. You'll film the machine running, and you might have some bloopers, so that's okay. Cut them out, condense it for time, and show me the completed run with an explanation of what the things do. Because once they run, sometimes they run very quickly and it's hard to see what's happening. So before you actually show the run, detail this will roll down the hill and knock the ball into the cup, which will weight the, yada yada. Explain what's going on. So again, checkpoint the 22nd, video by the 8th, either YouTube or Google Drive, and send me the link. Either way, that's totally fine. And then here's how I'm going to grade it. So you have this document that I'm pointing to, and then of course you have this big collection of videos from the past. I've got other Rube Goldberg machines from other students that you can see. There's one, I had a student that programmed his in Minecraft, which is, I think it's Minecraft, yeah, which is crazy. But there's other Rube Goldberg machines here. And so it'll give you an idea of how they work, as well as if you're looking for ideas of things around your house to use for a Rube Goldberg machine. I included this music video from a band that did it professionally. So this is professional engineers, but you can see the machine still uses spoons and guitars and bowling balls and things that you have around your house. It's not complicated in material, it's just complicated in design. So here is this I'm sending to you for your project ideas. Watch as many videos as you like. I'm also sending you this description of all the different projects. Whichever one you want to pick is totally fine. And then when we get closer to the 22nd, I'll pop you that Google form of just asking you which one you've decided to do. And then the final project, whether it's the mobile, the video, or the Rube Goldberg machine, will be due to me by February the 8th. Okay, hope you're doing well, and I look forward to seeing you again very soon.